Hello, welcome. Episode 34. We are still on moment of forces. So we have a uniform beam 6 meters long and weight 4 kg rests on support P and what? Q. Let's take it again. The weight of the beam is 4 kg and it is resting on a support of P, Q. Place left and right, which is 1 meters from each end of the beam. So weight of 10 kg and 8 kg are placed near where the P and Q is. The P and Q are just these are the support or the pivot respectively. So one on each end of the beam. We have to calculate the reactions at P and Q. If you watch the last 3 episodes, which is episode 31 to where we are now, you will get to know that we need to make a diagram and represent all the support and that of what the forces moving down and the reaction moving up. Let's check that out. So as we have the beam, this is our beam, which is what 6 meters long. We are bringing a weight at the end here, and there is going to be a weight at the end here as well. Remember, we don't have enough space, so we will manage. Then the weight of the beam is always at the central part of it, which is the center of the beam. So the weight is coming down. We have been told is 4 kg. Weight is M times G. So when I multiply, I should be having 4 times 10. That's 40 what? Newton. All right. There is a support which is measured 1 meters away. So let's say there is a support. This support is going to be P, which is on a measurement of 1 meter away from the end. Then there is also another support, which is also Q, 1 meter away. So if that is the case, then it means that there is going to be a normal reaction at where the pivot is placed. So let's say normal reaction 1. Then there is going to be a reaction here. Normal reaction what? 2. Now, the whole bar is supposed to be 6. So 1 plus 1, 2. The remaining here will be 4. Let's just put a 4 here. Good. So this is all that we can draw for this diagram. The beam, the support are PQ. Okay, we are left with the weight. The mass is 10. So if I put the 10 at where the force is, it will be 10 times 10, 100 Newton. 8 to Q, that will be 80 Newton. So let's go and take moment. So taking moment at, let's say we pick the first one, P. We want to take the moment at P. You can take moment at both ends so that we ignore one of the pivots. So if I take the moment at P, it means that I am ignoring the pivot Q. It is no more going to be there as a pivot. I'll be concentrating here to have my turning effect. So I should be having clockwise and anti-clockwise movement. So let's say sum of clockwise moment should be equals to, let's see, for a clockwise moment, when the beam is this way, the beam going down this way is clockwise. So as the 80 Newton is going down, the normal reaction is 1, is way up. So both are moving the same time. So clockwise, clockwise. Clockwise down, clockwise up. So we are going to have this and this. Now, if we are picking here, you see that the center of gravity is no more going to be here. We are looking here. So the bar is now from here to here, which is a length of 5. And 5 divided by 2 to give you 2 point something. So we be shifting somewhere here. So this force will also move along with the 80. Alright. So now let's see what will be the clockwise. Clockwise, R1. R1 is having a force, but the distance is 0 because we are still at the pivot P. There is no distance to multiply the force with. So the moment at the R1 will be 0. So let's go. If the moment here is 0, what should I be left with? I should be left with from here to here is 2. Because from here to here is, 4 divided by 2. Or 2 plus 1, 3. So we have 2. So I'll be having 2 as meter. Multiply the 4 at the center, which is what? 40. Then from the pivot all the way to where the Newton 80 is going to be 5 meters times the force 80. So 5 times what? Force 80 to 4. That will be 80. This will be giving you 400, and that will be 480 Newton meter. So that is giving us the sum of the clockwise what? Moment. Let's go to anti-clockwise. So sum of the anti-clockwise moment. Let's come here. We are picking the moment as P. So if we are going for anti-clockwise, the R2 will be moving up whilst the 100 Newton moving down. So R2 is moving at a distance of 4 away from the pivot. So I have 4 times R2 plus 100 Newton is moving 1 meter away from the pivot. So 1 times what? 100. And that will just give us 4. This is equals to, so 4R2 plus 100, all in Newton meter. Let's say if I can introduce Newton meter. Let's see, what is next? We have to move on to the principle. You will get more fat to solve this question if you watch the episode 31, where all the facts were laid down, the principles we need. So we can say that from the principles of moment, we say that the sum of clockwise, let me just use short form, the sum of clockwise moment will be equals to sum of what? Anti-clockwise what? Moment. You can write it in full. So what is the clockwise moment? 480. The anti-clockwise moment, 4R2 plus what? 100. We need to subtract 100 from both sides. So 480 minus 100, 4R2. This will be giving you 38, 0 equals to 4R2. Because of space, let's divide directly from here by 4 by 4. Your R2 should be equals to, I think, 36 here, so 9. Remember, 25 Newton. So the normal reaction at where the Q is going to be 95. Yeah, 95 Newton. How do we get the remaining one? We also have to know that from the principle, when the bar is in equilibrium, the upward force will be equals to the downward force. In order to balance the bar to be in equilibrium, we need to have the upward force, the sum of all the upward force equals what? The downward force. So we are saying that the sum of the upward force, what are the upward force? The normal reaction here. Reaction 1 plus normal reaction 2 equals to the downward forces will be 100 plus 40 plus what? 80. We already know reaction 2. So 4, okay, this is R1 plus 95 equals to this is going to be 220. So your R1 should be equal to 220 minus what? 95. We have 125 what? Newton. So the reaction at both P and Q will be 125 Newton and 95 Newton. I believe concept is clear. Like, share, comment, and subscribe.